welcome student to our channel, the one and only Physics Point. And this is the lecture number 2, and we have started discussions of the new chapter, that is the Mathematics 12th Standard Mathematics Part 2. And the name of the chapter is the Differentiations. In these lectures, we have solved some problems, some numericals from the exercise 1.1, that is Maharashtra State Board Standard 12 Mathematics Part 2, chapter number 1. The name of the chapter is Differentiations. Name of the chapter is Differentiations. In the previous lectures, we have studied the introductions of the differentiation, what is the exactly meaning of the differentiation, and try to understand and remember the formulas which is useful to solve or differentiate the different types of the functions. And there are 11 to 12 different formula to differentiate the functions which are algebraic functions, trigonometric function, exponential functions, as well as the function inside the root and the functions having the multiple or positive or negative integers powers. And before wasting time, just start discussions or solving the first problem. This is the question number 1. Differentiate the function with respect to x. That is the functions. First one, the x cube x cube minus 2x minus 1 bracket raised to 5. This is the functions treated y, which is equal to x cube minus 2x minus 1 whole bracket raised to 5. When we see these problems or these functions are in the form of variable x. The y is the function in the form of variable x, which having the some n, that is x raised to n. We use the formula that is x raised to n for solving these problems. Differentiate the function with respect to x. Differentiate the function with respect to x. Now dy by dx, which is equal to d by dx, that is x cube minus 2x minus 1 bracket raised to 5. Apply the x raised to n formula. What is the formula? That is x raised to n. Differentiate of their functions which having the x raised to n, which is equal to n into x raised to n minus 1. This is the formula to calculate or differentiate the functions which having the n number of indices. Then first here is the functions will be x. The x cube minus 2x minus 1 is treated, whole function is treated as a x, and the n, which is equal to 5. Apply the formula, that is n into x. X is, that is x cube minus 2x minus 1, and differentiate the remaining functions or whole functions again with respect to x. Inside the function which we have treated x, that is x cube minus 2x minus 1, which is differentiated or which is separated with the positive or minus symbols. That means each and every term differentiates separately with respect to x. That is dy by dx, which is equal to 5 x cube minus 2x minus 1 into d by dx of the first term, that is x cube minus 2 is a constant which is multiplied with respect with a variable x, and differentiate d by dx of the x. And we know that the differentiation or derivative of the functions which are constant with respect to x is 0. That means differentiation of the minus 1 or positive 1 will be 0. Minus 0 is same functions. That's why we don't take that. That is dy by dx, which is equal to 5x cube minus 2x minus 1 raised to 4. Here we are missing some terms, that is 5 raised to 1 raised to 4 here, and d by dx, or what is the x cube, that is 3x square into minus differentiation of the function x with respect to x is 1 and 2 into 1 is 2. Now dy by dx, which is equal to 5 into this function, that is 15x square minus 10 into, that is x cube minus 2x minus 1. This is the differentiation of the functions, that is x cube minus 2x minus 1 whole bracket raised to 5 with respect to x. Now, what is the second question number 2? Second will be, that is here second, that is 2 x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 whole bracket raised to 5 by 2. Here we use the x raised to n formula multiple times. Then we solve this question. The functions y which is equal to 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 whole bracket raised to 5 by 2. Differentiate this function with respect to x and apply the formula, that is x raised to n. Differentiate with respect to x here. dy by dx which is equal to d by dx of, that is 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 whole bracket raised to 5 by 2. This 5 by 2 is treated as n and whole function, that is 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 which is an x, and apply the similar formula which is written here previous for the previous question, that is x raised to n minus 1. Now dy by dx differentiate with respect to x, that is 5 by 2 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 which is 5 by 2 minus 1 and minus 1, and again separate differentiate the function, that is d by dx of the function, that is 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 here. Then this term written here, that is dy by dx which is equal to 5 by 2 into the function, that is 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 whole bracket raised to 5 by 2 minus 5 upon 2 minus 1 which is equal to 2 into minus 1, 5 minus 2 upon 2 which is equal to 3 by 2, and separate differentiation of these all functions into 2 is taken common. Differentiation of these functions, again use the same formula, that is x raised to n minus x raised to n into x raised to n minus 1, that is into 3 by 2 into x raised to 3 by 2 minus of 1 minus the second functions 3 as it is into, that is 4 by 3 into x raised to 4 by 3 minus 1. We know that differentiation with respect to x of the any constant is 0, that's why minus 0. Almost done. dy by dx which is equal to 5 by 2 into the function, that is 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 whole bracket raised to 3 by 2 into, here the product 2 gets cancel, 3 gets cancel, that means 3x raised to 3 by 2 3 by 2 minus 1, that is 1 by 2 minus 4 into x raised to 3 by 2 4 by 3 minus 1, that is 1 by 3 minus 0 as it is. This is the final answer of that questions. Differentiate with respect to x of the function. So functions will be y which is equal to 2 into x raised to 3 by 2 minus 3 into x raised to 4 by 3 minus 5 whole bracket raised to 5 by 2. These whole functions will differentiate with respect to x. Then we get 5 by 2 which is into 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 whole bracket raised to 3 by 2 into 3x raised to half minus 4x raised to 1 by 3. This is the answer of that functions. Then we are going to next one. The next one, question number 3 will be under root x square. Third one, under root x square plus 4x minus 7 here. The function y which is equal to under root, that is x square plus 4x minus 7. We know that differentiation of the functions which are under the root, under root x, d by dx of under root x, which is equal to 1 upon 2 root of x. And if the functions are placed at the place of x, function is hidden inside the function, that means x is a whole function, that is z of x, that means again differentiate this function with respect to x. That means differentiate this function with respect to x. Now dy by dx, which is equal to 1 upon 2 root of, what is the value of x? X square plus 4x minus 7 treated as whole x, that is x square plus 4x minus 7 into differentiate the remaining function, that is x square plus 4x minus 7. Then we know that dy by dx, which is equal to 1 upon 2 into root of x square plus 4x minus 7 into differentiations of the function, that is d by dx of x square plus 4 is a taking common because it is a constant multiply with the function, that is d by dx of x. We know that differentiation of the function which is constant, it must be 0. Now next step, dy by dx, which is equal to 1 upon 2 root of x square plus 4x minus 7 into, what is the function? Differentiation of x square with respect to x, which is apply the same formula, that is x raised to n. N means 2. 2 into x raised to n minus 1, that is 2 minus 1 is x raised to 1, that means 2x here. Plus 4 as it is. Differentiation of the function x or differentiation of the variable x with respect to x is 1 plus into 1, which is 4, and minus differentiation of the constant is 0, it is minus of 0. We know that dy by dx, which is equal to, we take the common from the both terms, that is 2 into x plus 2, which is divided by 2 into under root of x square plus 4x minus 7 here. 2 gets cancelled. The final answer of the function, which is under root x square plus 4x minus 7, which is differentiate, after the differentiate with respect to x, is dy by dx, which is equal to x plus 2 upon under root x square plus 4x minus 7. It is the final answer of that questions. There are some several another problems in the question number 1 from the practice at 1.1, which you solve in homeworks as same pattern. And the question number 2, first question from the question number 2, we solve here. That is the first, cos of x square plus a square. In the question number first, all the problems are from the algebraic functions. In the question number second, the questions will be changes. That means the capacity of the questions are also changes, thinking ability also changes, and we try to think some different out of the box when we solving the different questions. In the question number second, we solve all types of the questions, which are trigonometric functions, square root functions, inside the square root some exponential function, inside that exponential function some algebraic functions, and logarithmic function, trigonometric function, algebraic function also. The all types of the questions will be solved in the question number 2. All functions will be solved, or differentiation of all types of the questions. Then cos of x square plus a square. Our first target will be treated x square plus a square as a single parameter, which is x. We know that what is the differentiation of cos x is a minus sin x, and what is the x at the place of x, which is x square plus a square. Again differentiation this function, that is x square plus a square with respect to x. This is the whole pattern or our path to solve this question. Differentiate with respect to x. We know that dy by dx, which is equal to d by dx of the function, that is cos of x square plus a square here. X square plus a square. We know that first of all differentiate cos functions, differentiate cos of x square plus a square with treating x square plus a square is a only single parameter, that is x. And what is the differentiation of cos x, which is minus of sin x, d by dx, which is equal to minus of sin, what is the value of x, x square plus a square. Now again differentiate this x, which is x square plus a square. This function which is treated as a. Now the second step, dy by dx, which is equal to minus sine of the function x square plus a square. These two different parameters or two different terms in the functions which is separated by the positive signs or plus symbol. That means we differentiate separately into d by dx of x square plus d by dx of a square. We know that final answer is written here. That is dy by dx, which is equal to minus sine of x square plus a square into differentiation of the function x square with respect to x is, we apply the similar formula, that is x raised to n, that is 2 into x raised to n minus 1, that is 2 minus 1 is 1, 2x, and a or a square is a treated or it is assumed as a constant, or it is a constant with respect to x, because these functions will be changes with respect to x. As per, if the function is changes with respect to x, that means a or a square treated as a constant. That means the constant of the derivative is 0, or derivative of constant is 0, that is plus 0 here. Now dy by dx, which is equal to this 2x taken first minus 2x into sine of x square plus a square, which is the final answer of the question number first, of the first question from the question number second, which is included in exercise 1.1. As similar questions, we try to solve the next question number second sub question from the question number 2. Now second question from the question number 2, under root of e raised to 3x plus 2 plus 5 here. E raised to x plus 5, it is a function at the place of x, that is 3x plus 2 is the z of x, which is function hidden in the f of x. First of all, we try going inside that functions from the outside. When we are going inside, we first face square root, and then we know the e raised to x plus 5, that is function. When we are again going again deep inside or deep in the question, that times we know that 3x plus 2. That means first of all solve the square root, apply the square root formula. After the applying the square root formula, then apply exponential formulas. After the exponential formula, then at the end of these questions we apply algebraic functional formulas. And we know that this function, inside that functions which is variable x, that means differentiate this function with respect to x. Differentiate with respect to x here. Now dy by dx, which is equal to d by dx of the questions which are under root e raised to 3x plus 2 plus 5. We know that what is the function, what is the differentiations of the square root of x, which is dy by dx, which is equal to 1 upon 2 root of e raised to 3x plus 2 plus 5 into differentiate the function, that is e raised to 3x plus 2 plus 5. The function which is e raised to 3x plus 2 plus 5, which are separated by the positive sign, that means we apply the separate differentiation That means dy by dx, which is equal to 1 upon 2 into root of e raised to 3x plus 2 plus 5 into d by dx of e raised to 3x plus 2 plus d by dx of 5. Second question, we know that the differentiate with respect to x of any constant which is 0, that means the differentiations of the second term, that is 5, will be 0. Now dy by dx, which is equal to 1 upon 2 root of e raised to 3x plus 2 plus 5. We know that differentiation of exponential function with respect to x is the same function. That means e raised to 3x plus 2 again plus 0, and again differentiate of the 3x plus 2 plus 0, that is differentiation of 5. Now final step, dy by dx, which is equal to, at the numerator, that is e raised to 3x plus 2, which is divided by 2 into, that is e raised to 3x plus 2. Now here there are two different terms which are separated by addition sign, again differentiate separately, but we know that plus 2 is a constant parameter. Differentiation of any constant is 0, that means we just differentiate 3x with respect to x, then write the final answer. 3, which is a constant which is multiplied with the x, we taken outside, and differentiation of x with respect to x is 1. Here we just multiply by 3. The final answer will be dy by dx, which is equal to 3 upon 2. 3 upon 2 into e raised to 3x plus 2, which is divided by, inside the square root, e raised to 3x plus 2 plus 5. This is the final answer of the differentiation of these questions, which are under root e raised to 3x plus 2 plus 5 here. And I want to solve next one last questions in these lectures. In the next lectures, I try to solve. Please solve these questions for homework, and we are trying to solve question number sub question 5 from the question number 2 in the next lecture. Okay. The last question from this lecture. Next one. Question number 3. Log of tan of x by 2. In these questions, we facing first logarithmic functions, then trigonometric function. Inside the trigonometric function, we got the algebraic function. First of all, we differentiate logarithmic function using the logarithmic formula. At that time, tan of x by 2 treated as a single parameter, that is x. Then solve the differentiation or differentiates of tan of x by 2. At that time, x by 2 is treated as a only x. Y, which is equal to log of, that is tan of x by 2, differentiate the function with respect to x. We know that dy by dx, which is equal to, what is the differentiation of log x? We know that differentiation of logarithmic function dy by dx of log x, which is equal to 1 upon x. Here we treated tan of x by 2 as a x, that means 1 upon tan of, or first step, it is d by dx of log of tan of x by 2. dy by dx, which is equal to 1 upon tan of x by 2 into d by dx of tan of x by 2 here. We know that dy by dx, which is equal to 1 upon tan of x by 2 into differentiation of tan x is the sec square x and x is an x by 2. Again differentiation, that is x by 2, d by dx of x by 2 here. Now final answer here, dy by dx, which is equal to sec square x by 2 upon tan of x by 2. Here we use some expressions or some trigonometric formulas to again splitting, that is sec square x by 2, that is 1 upon cos square x by 2, which is tan is a sin upon cos, cos is getting multiplied in the numerator. There are changes some different. Into d by dx of x by 2, we taken 1 by 2 as a common and differentiation x is a 1. 1 by t, 1 by 2 taken common and differentiation of x is 1. 1 by 2 is multiply here. The final answer will be dy by dx, which is equal to 1 by 2 into 1 upon cos square of x by 2, which is divided by sin of x by 2 upon cos of x by 2. 1 cos x by 2 will be cancelled here. That is cos x upon sin x, that is dy by dx, which is equal to 1 by 2 into 1 upon cos of x by 2 into sin of x by 2. Which formula is applied here? 2 cos x by 2 into sin x by 2, which is 2 into sin of x by 2 here. And how to solve the question number 4? First of all, we apply the formula for root x, that is 1 upon 2 root of tan of under root x. Then again solve the differentiation of tan of root x, that is tan sec square root x. Again apply the formula for a root x, that is 1 upon 2 root x. Final answer will be sec square of root x upon 2 into 2, that is 4 root under root of tan of root x into root x here. Okay, that is final answer will be dy by dx of the fourth question will be sec square of root of x, which is divided by 4 into root x into under root of tan of root x here. This is the final answer. Try to solve these questions, and in the lecture number 3 try solve the remaining questions from the question number 2 and solve this question number 3. Okay, thank you.